Hello, Rohan. How are you doing?
I'm good, sir. How are you?
Very good, very good. So, in maths, what are you doing these days?
So in maths, just started geometric properties.
Mhm.
So right now we are doing verifying properties of quadrilaterals.
Perfect. So, you have already done properties of triangles, correct?
Yes, sir.
No difficulties there. You have understood everything.
No, sir. I have understood everything, so there's no difficulties.
Perfect.
So in like for triangles, like one of them was like the special like for isosceles that the adjacent line, the midpoint and the angle bisector for isosceles, they all coincide into one line. You would have a centroid found in the middle of all three of the midpoints when lining up each one of them.
Mhm.
And there should be like an equal distance between each other. And another one which learned was like a ratio of 2:1. I
Two is
think that were like the line,
for
double line.
centroid. For centroid.
Yeah.
Centroid is the point of intersection of all the medians in a triangle, and its ratio from the vertex to the midpoint. That is in that centroid is divides that line in the ratio of 2:1. Correct. That's perfect. So let's begin with the quadrilaterals. If you want, you can share your book and I'll explain you what you're going to learn in this chapter and how to attempt these questions.
Okay, sir.
You can
I'm
share the
just gonna
screen.
start sharing my screen.
Verify properties of quadrilaterals. First thing first, what is a quadrilateral? Can you tell me?
It's a four-sided shape.
Yeah, so we are talking about four-sided figure, right?
So like a square, rectangle, parallelogram.
Rhombus. Yes, that is right. Let's move on and take some examples, and from there we'll begin our work.
Okay, sir. So,
So, what is example number one?
in a first example is the midpoints of a quadrilateral.
Correct.
So it says that verify that quadrilateral EFGH formed by the joining of midpoints of adjacent sides of quadrilateral ABCD is a parallelogram.
Correct. So, what they're trying to also tell you in this process is that if you take any quadrilateral, E, F, G, H, in that case, if you join the midpoints, you will get a parallelogram um, in the center, right? So, when you join it. So, in this particular case, they have already given you the four vertices of the quadrilateral. So, midpoints you can find, correct? You know the midpoint formula, correct? What is the
Yes, sir.
midpoint formula?
So x1 plus x2 over 2 and y1 plus y2 over 2.
Correct.
Isn't there also like another formula, sir? Like x equals to x1 plus half and then brackets x2 minus x1?
Well, you can write it in different ways, but this is simplest and the best formula to use in most of the cases. Is that okay?
Yes, sir.
Good. Another thing which we might need sometimes is the distance formula, right? So let me write down distance formula also. Distance will be square root of x2
x2
minus
minus x
x1 whole square.
squared.
Yes. Now, whenever you begin your work, it's important to write down all the formulas on the side so that, we have a reference to look at. And by this process, you can always learn and remember these formulas, right, as you move along. So simple as
Okay.
that. So how will you show that? We need to show that EFG, E, EFGH is a parallelogram.
So then what I would do, sir, is since we already got the coordinates of A, B, C, D, it's
Yeah,
best to find midpoints of all of them.
correct.
So like E, F, G, H.
Yeah,
That way, when we have it, we can just join the lines together to form our parallelogram.
correct. So individually, you just find the midpoints, which is very simple to do in this case. Add the x values and divide by 2. So h will be what? Minus 4 plus 1 divided by 2, correct?
Yes, sir.
So what do you
So
get?
that would be so x1 plus x2 over 2. So that would be negative 3 over 2, sir, for x. And for y, it should be 7 over 2.
So why did you take 7? 5. When you add them, you get 7. 7 over 2 is correct. So you have these 2 points. You can also write them in decimals if you need, right? You could do that, correct?
Okay, sir.
Similarly, you can find all the points as has been found in the example, correct? So first step is find these midpoints, E, F, G, H, correct?
Yes, sir.
Those values are given to you. Now, once you have found the points, to prove that this is a parallelogram, what will you do?
So then we have to find the slope, sir. So the slope of each point.
Yes. Slope between each point. So you have to show that G to H is parallel to
E to F.
E to F. If I write G, then I'll write F to E. Is it okay? And also, you have to show that E to H is parallel to F to G. Is that okay?
Yes, sir.
G to H is parallel to F to E. Sorry, this was F.
Oh yeah, FE.
Yeah, FE. Okay. So we have to show that. To show that these lines are parallel, you have to find the slope, right?
Yes, sir.
So then you find the slope of GH, and that should be equal to slope of FG. And
FG.
similarly, slope of EH should be equal to slope
Slope
of F.
FG.
So this is FE, right? Sorry, FE, right? So
Yes, sir.
formula M is Y2 minus Y1 over
X2
X2
minus.
X1. Simple as that. So once you do that, you can check that these slopes are equal and therefore the lines are parallel. Another thing which you could do is also find the length of opposite sides. Length should also be equal, correct?
Okay, sir.
So
So
let's
like
move. Yeah.
point for an example, would we also be able to do like opposite like diagonals like E to G, F, H to E? I mean H
That
to
is
F.
that is not required. So parallel, once you have proved in a quadrilateral that opposite sides are parallel, it becomes a parallelogram by definition, right? So sometimes they might say that show in more than one way that this is a parallelogram. So then the slope also can help you to figure it out. Now let's look into the example and see what exactly has been shown in this particular example. So move forward.
Okay, sir.
So they are verified with the help of slope that the slopes are same, correct?
Yes, sir.
And therefore, as you can see, these slopes are same, equal to minus 10. The other slopes are minus 5 over 11. Is it okay? So the
Yes,
slopes
sir.
are same. So let's move forward.
Okay. And then here they wrote their concluding statement.
Correct. Now, it is very important to use the one of these strategies because, as you can see, in examination, we are looking into the time is a big constraint. You get the idea.
Yes, sir.
Time is a big constraint. So therefore, we cannot really do all the things every time. You get the idea.
Yes, sir.
So that's why slope is the fastest way of getting to the proof that that was a parallelogram. Perfect. Now let's look into the next example. Example 2. Can you read the question, please?
Okay. So verify that the quadrilateral with vertices 3, 3, so P 3, 3, Q 0, 1, R 3, negative 1, and S 6, 1 is a rhombus.
So what are the properties of rhombus?
So they're quadrilateral, and isn't it that they like they're right angles? Like the opposite sides are similar?
So it's a
Like their
parallelogram, right?
sides are equal, isn't their sides are
It's a
equal?
parallel, opposite sides, parallel, right? All equal sides. So it is a parallelogram with all equal sides. The length of each side is equal. All the 4 sides are of equal length. You get the idea.
Yes, sir.
So the key parameter here is length formula, right? So length of all 4 sides is same. Is it okay?
Okay, sir.
Right. Just as in a square also length of all 4 sides is same, but in a square it is at right angles. In a
So
round, in a rhombus, it may not be at right angles, right? So square is also a rhombus. Remember that part. Okay.
Okay, sir.
It could be
So
any angle.
it's basically all four lengths are the same, right, sir? For
Correct.
the rhombus.
Right. Another
Okay.
important property of rhombus is that when we have a rhombus, let's say, let me just make one rhombus. In that case, the diagonals, they intersect, they bisect one another. So they are at right angles and they bisect one another. Do you see that?
Okay, sir.
So they are
And sir, for
rhombus.
this one,
Yeah.
I'm sorry for cutting you. But for this one, right, sir?
Yeah. Yeah.
So does that mean that when we look at midpoint, right, sir, if we were to find the midpoint of the diagonals, right, sir,
Each diagonal.
both sides should be equal for all of
Exactly.
them?
Yes. 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 So when we find the midpoint of each diagonal, it will overlap. So that's the best way of finding the midpoint or the center of or point of intersection of the diagonals when we are talking about a rhombus. Is that clear to you?
Okay, sir.
Yeah.
But is it true that, let's say, if we wrote A, B, C, D, right,
Yeah.
sir?
Yeah. Yeah.
Like A at the top, like top left hand, B on the top right hand,
Okay.
C on the
Okay. Let's
top
write.
left hand,
Yeah.
and all
Yeah.
that.
Yeah.
So does that mean that if, let's say, we had diagonal line D, right?
Yeah.
And we
BD.
put AC on top, D
Yeah.
and BD would be split in half, but AC wouldn't.
No. AC, this point will be midpoint. So A to O will be equal to O to C.
And same
And
for
B
O
to
to
O is
D and
also
B
equals
to
to O
O.
to D. Is also equals to O to D.
Okay, sir.
Individually. Yeah. Yeah. Individually. They will be of different lengths, although, because it's an angle, correct? So one will be a
Yeah.
shorter diagonal, the other one will be a longer diagonal. However, they will intersect. Diagonals will intersect at a point so that each is divided as a right bisector.
Okay, sir.
Yeah. So verify the quadrilateral with these given vertices is a rhombus. You should find the distance between the points, right? So the length. So when you find the length of each side, it has to be exactly same. As you can see here, it is square root 13, correct? And therefore,
Yes, sir.
it is a rhombus. Is that clear to you?
Okay, sir. Because they all have the same sides length.
Correct. That is why. What is part B? Verify that the diagonals of this bisect at right angles. So what will you do? You'll find the slope of each diagonal, correct?
Yeah, so we had have to find the midpoints of each one of them, sir.
No, you can just find the slope and then, yeah, you can just find the slope, right, for each diagonal, and the slope will be negative reciprocal, correct? So there are
Okay,
two
sir.
things. One is slope of diagonals will be negative reciprocal.
Okay, because they're like one is going from left to right, another one's coming down from left to right.
Correct. Slope is negative reciprocal. Second, you can also, and because they are right bisector, right means they should intersect at right angles, correct? Bisector means equal length of each side. Right? So let me again draw this rhombus general. Right. So we'll do find the midpoint of each. So when you find the midpoint, so find the midpoint. Of each diagonal. It will coincide.
Okay, sir.
So if the midpoint coincides means, both the diagonals are
In one.
intersecting right in the center, correct? And we have found the slope at right angles. That means we have proved that they are perpendicular
90 degrees.
perpendicular bisectors, correct?
Okay, sir.
They are perpendicular
So
and bisectors.
so perpendicular bisectors are like they're not similar to right bisectors, right, sir? Like because they're supposed to be bisecting at 90 degrees.
Right bisector, the same thing. Right bisector and perpendicular bisector, same thing. So in case of
Okay.
a triangle, you're joining the center point and then bisecting it, right? So bisecting means, of any case, bisecting really means if I have a segment, right? So to bisect means to find the midpoint, right? And perpendicular means at right angles. Do you see that?
Yes, sir.
So we have both the properties, and that is the sides will be equal and the angle will be 90 degrees.
Okay,
That
sir.
becomes perpendicular bisect.
Okay, sir. And here, what they did was they first solved the midpoints for PR and then RE, sir. I mean,
Yeah.
QS.
Yeah.
Okay.
And
So what they
they
did
got the
was they
same
found the
midpoint.
distance.
They found the same midpoint. Do you see that?
Yes, sir.
Yeah.
So basically, they just used the distance from each other to find it, and then they just go drew, and then
So,
afterwards they used both the lines to find the midpoints of each other,
hmm,
and then they use slope afterwards to just check and see if it would actually work.
if it is perpendicular. So
Yeah.
slope you find to show that it is perpendicular, and midpoints coincide means it is bisecting. So those two things, correct?
Okay, sir.
So diagonals bisect each other because their midpoints match, and slopes are negative reciprocal. One is zero,
Yeah.
the other one is undefined. That means they are perpendicular. So it becomes perpendicular bisector.
Okay, sir.
Two conditions, and this is how you prove that. Perfect. So let's move on and take the next example. Can you
So
please read the
the
key
key concept.
concept? Yeah.
So here it tells us that the formula for lines, midpoints, and slopes to verify properties of quadrilaterals often there's more than one way to verify property of a geometric shape.
Correct. Correct. So you have to figure out which is the best and the fastest way to prove it so that in examination you save your time.
So mainly it's just like selecting a method and then
Best
wanting
method.
to
Yes.
test.
Okay, now communication. Stop, stop, stop. This is a very interesting question here. Can you read C2?
C2. So describe how to verify the point of intersection of diagonals of a kite EFGH bisect only one of the diagonals.
Yeah, tell me how this shape given to you is kite. So in case of a kite, how will you prove that this is a kite? Tell me.
Wait, sir, so how is like a drawing of a kite like supposed to be?
Okay, let me just show you a drawing. I'll make it like this, right? So what you notice here in the kite is that two sides are, these sides are equal and these sides are equal. Two set of equal sides are there. Do you see that?
Okay, sir.
The most important property of this kite is, which you will most of the time use, is that it has two diagonals, as all quadrilaterals have. So that is the one shorter one, and this is the longer one. So one is called major, one is called minor diagonal. Is that okay?
Okay, sir.
Now, in this particular case, both the diagonals for a kite will always intersect at right angles. So diagonals,
So is this like a special property, sir, that like all quadrilaterals should intersect having 90 degrees?
none, all do not. So only kite, square, and rhombus, they intersect at right. Diagonals intersect at right angles.
So kite, square, and rhombus?
Yes. So this property is shared by also with, let me write kite also here, square and rhombus.
Okay.
Only these three, because all this is very critical property, right? Now, in case of a kite, another special thing is that only one side is bisected. Do you see this thing? The other diagonal is not bisected. One
Okay.
diagonal is bisected. Well, I'll say minor diagonal. Minor diagonal is bisected.
So, sir, there's a minor and major diagonal?
Yes, one is smaller, one is bigger. as you can clearly see in case of kite, because one set of sides which are adjacent, right? So, and what you see here, adjacent sides are equal. Adjacent equal pairs,
Okay, sir.
as you have seen in this particular diagram, right? So these are very typical properties of a kite. So in the given diagram, what will you do? You will find the diagonals slope, right? So
Yeah,
slope of these diagonals, right? And then that slope should be negative reciprocal.
negative risk.
So
Okay,
that is the
sir.
first thing. So you'll find the slope of the line, which is F2H. That should be negative reciprocal of slope E to G. Is it okay? So
Yes,
that
sir. So
is the
whatever you got for F and H, sir,
yeah,
as your slope, it will always be the opposite. So you flip the sign and the
correct,
numbers.
correct, perfect. And to show that this is the midpoint, you find the midpoint of minor r. Is that okay? And that will
Okay,
follow on
sir.
the other diagonal. Is that okay?
All right, sir.
So
Sir, do
find
you
mid,
also have to like check to see if there's like equal distance between the two of them as well or no?
when you find the midpoint, midpoint means equal distance. You get the idea? So you
Yes, sir.
find midpoint of the point
FH.
FH, midpoint of FH, correct?
Okay,
So
sir.
midpoint of FH, whatever you find, it should lie on EG,
Okay, sir.
lies on line E to G,
EG.
right? So you have to find equation of line EG, and that midpoint will follow there. That means it is a point of intersection between the two. Is that clear to you?
Yes, sir. And when we find it, do we have to create like a y equals mx plus b equation, right,
Yes,
sir?
yes. You using E to G. Yes, you have.
Okay, so like midpoint, slope, and then y equals mx plus b, and then using the points given to us.
Perfect. So this is a very good, interesting exercise which you can actually do now, right? Is that clear to you? You can actually do it.
Yes, sir.
So shall we do it? Find the midpoint of F to G. Make it
Okay,
smaller.
sir.
Yeah. Let's find midpoint of F to G. So first thing is verify the slope, right? So find the slope of F to H.
So FH.
Yeah.
So that would be
4 minus 2 over 3 minus 1, right?
yes, sir.
3 minus
So
1.
that's
So that is 2
4 minus 2
over
over 3
2,
minus. I got 1, sir.
1, right? So this is the slope. Now find the slope of E to G.
E to G, okay.
So E to G slope is 4 minus 0, y2 minus y1, right?
Yes, sir.
Yeah, calculate 1 minus 5. It is my 4
I
over
got
9.
-1, sir.
Perfect, negative 1. You can see 1 and negative 1 are negative
Our
reciprocals,
slopes.
right? So you
Yes,
can
sir.
also say that MEG times MFH is equal to 1 times -1, which is equal to -1. So their product is -1. That means they are negative reciprocal of one another. So we have verified that they are perpendicular. Is that clear to you?
Yes, sir.
So one part is done, which we have verified. The second part for us to prove is that the midpoint lies on the line E to G. So let's
G.
find the midpoint of F to H. Let me change the color. So 1 plus 3 divided by 2, comma 2 plus 4 divided by 2. I wrote 4 first. Okay. So which is 2 and 6, 2, 3. Correct?
Yeah, I got 2 and 3, sir.
Perfect. What is the equation of line EG? Find equation of line EG.
Okay.
We already have slope of EG, right? Slope of EG is -1, correct?
Yes, sir.
So
So, sir,
slope
I
of
got 3 and
-1.
2.
So you can now write down the equation. So y equals to mx plus p and then substitute, or which equation do you use? Y minus y1 equals to m times x minus x1?
For which one, sir?
Y minus y1 equals to m times x minus x1. You don't use that one, right?
No, sir.
You use y equals to mx plus b, correct?
Yes, sir.
So you have y equals to minus x plus b. Substitute x and y points, which is 1 and 4 or 0 and 5, right? You can substitute 5 and 0. So we have 0 for y and 5 for x, and therefore the value of b is 5, correct? And so
Yes, sir.
you have the equation which is y equals to minus x plus 5, correct?
Yeah.
You have to verify that the point 2, 3 lies on it. If you put 2 for x, what do you get?
If you put 2 for x, then you should get 3. So
Yeah.
in this case, you would get negative 2 plus 5, which is 3.
So the point lies on it. Do you see that? So we have
Yes, sir.
shown that this midpoint, which we calculated, lies on the line. So that means the two diagonals actually bisect at that particular point. Is that clear to you?
Yes, sir.
So that is how we are going to do. So what you have also learned here, that if you find the midpoint, find midpoint. Then no need to find distance. You understand?
Yes, sir. If you find midpoint, then you don't have to find the distance of a line.
To show that two sides are equal, right?
Yes, sir.
Yeah, to show that two sides are of equal length. Is that clear to you now?
Yes, sir.
See, because the length formula requires the difference of squares and then square root. A lot of calculation is required there. Avoid that calculation by finding the midpoint. Is that clear?
Yes, sir.
Perfect. So I hope this is absolutely clear. We can take up some questions from the exercise. So we can move forward. So we'll skip few easy ones because those types we have already done. Let's move further, right? Okay, let's see question number 11. What is it?
Okay, 11. So draw the quadrilateral with vertices A, B, C, D. Then
Correct.
join the midpoints of the adjacent sides of A, B, C, D to form a new quadrilateral E,
Yep.
F, G, H.
Mhm.
So then
Verify.
verify that EFGH is a rhombus and describe another method for verifying that EFGH is a rhombus.
Correct. So you verify and re-verify. So multiple, see in this question straight away, they are checking both the ways, right? So what will be your two ways of verifying that it's in rhombus?
So verifying that it's a rhombus. So what I will do is, if I need to verify that it's a rhombus, is that I already know that when we're doing the diagonals intersecting, there should be having 90 degrees, and that all for the exact same for the sides.
Easiest way is all four equal sides. So find the length and then you are verified. Is that clear to you? It's a rhombus.
Yes, sir.
Correct. Now, the other way you said is midpoints coincide, right?
Yeah.
Midpoints of diagonals, right? They will coincide.
Yes, sir.
So midpoints of the diagonals coincide means that they are bisecting centrally, correct? However, it is not saying that they are right bisectors. Do you see that? And
Yes,
then,
sir.
so part A, this is your part A, and part B will be slope of diagonals.
Okay, slope of diagonals.
Yeah.
Okay,
For
sir.
perpendicular, yeah. For perpendicular, verify that the product of slope, let me write, of diagonals is how much? -1, correct?
-1. Yes, sir.
So that is what you have to do this particular question 11, which is actually similar to one of the examples which we did. Is it absolutely clear to you?
Yes, sir.
So that is what we have in verifying properties of quadrilaterals. You can read question number 12. Let's see if you can do it.
So draw the quadrilateral with vertices P, Q, R, S,
Mhm.
and then draw the diagonals of P, Q, R, S.
Correct, correct.
Okay,
Very,
so what they're saying is that first we have to sketch the quadrilateral and then draw the diagonals to show.
yeah, yeah,
And then it's second, it says that verify that the diagonals bisect each other and
correct.
see what kind of quadrilateral is PQRS.
And justify your answer, right? So now you know all the properties of quadrilaterals. You can justify whether it is a parallelogram or it is a rhombus. You understand?
Yes, sir.
Yes, every rhombus will also be a parallelogram. Clear, right? But not necessary that, whenever you join the midpoints, you get a rhombus. You might get just a parallelogram. Is that clear to you?
Yes, sir. So then how would you identify if it's a parallelogram or a rhombus?
That is that they will be not perpendicular diagonals. So if the diagonals are perpendicular, it is rhombus. You get the idea?
Okay, and if not, then it is a parallelogram.
Yes. So it could be yes or no, right?
Yes, sir.
And if it is yes, in
Then,
that case, rhombus.
okay, sir.
If it is no, it's parallelogram. I write parallel lines and GM for gram. So parallelogram.
Okay.
Is that clear
So
to you?
just, yeah, could you just leave it for a little bit? I'm just gonna write it down.
Sure, sure, sure. Take a snapshot.
Diagram. All right, sir, I got it.
Perfect. So I hope with this we can end the class. You can actually try all these questions. Plus, you can also work on my YouTube video channel, some questions from there where we have some past questions, right? So if you want, what you can do now is we'll end this session on the book. You can search my video, say Anil Kumar, MPM2D, geometric properties of quadrilaterals, and see what videos you get, right? So I'll clear,
Okay, sir.
you can clear the screen. Yeah, we
All
can
right,
go to
thank you very
YouTube.
much, sir.
So on YouTube, you can search Anil Kumar. MPM2D is the course name for you, right? MPM2D
Okay, sir.
playlist. Just do it. MPM2D test playlist.
All right, sir. I'm just opening it up.
Yeah, do that.
MPM2D, right, sir?
Yeah, yeah. That's the course name for this grade
And this
10.
is which one, sir? So
Uh,
MPM2D geometric
okay, right. Playlist.
playlist. Wait,
You can share the list. Share the screen so that I'll tell you which one to look into.
yeah, I'm just starting to share it.
Okay.
You able to see it, sir?
Yes, I can. So you see the very first video we have. It gives you many questions from previous test paper. It says MPM2D, Analytical Geometry, exam review for grade 10. So it includes all of the chapters also.
So this is the one I should choose,
No,
right,
no,
sir?
you choose the next one because you're doing especially the
Oh,
geometry.
this one, right, sir?
Yeah, next one, 26-minute video. And then we have a playlist. In the playlist, there are 40 videos, which will cover so many examples of what we have done. So for now, you can run this video, which is 26 minutes.
Okay,
Analytical
so
geometry test.
2652, right, sir?
Yes,
This
yes.
one?
Run this one.
Okay,
So
sir.
these are multiple choice questions. You should look into these, try to answer these questions, and then check with my solution. That'll be good for you. Okay?
Okay, sir.
Correct. So first one is the line perpendicular to a segment joining these points and the origin is what? So we are starting from the beginning so that you can build on the concept and then answer more questions. Is that clear to you? Right?
Yes, sir.
Now you can go to the middle part of it for now. Later on, you can go through all these questions one by one. Yeah, anywhere, somewhere in middle. Yes. So can you read this question?
So for triangle with vertices x, y, and z, find the equation of the median from vertex x.
Correct.
So this is telling us that when we sketch our triangle XYZ, that from vertex X, we should find the midpoint.
Correct.
So we would just have to do midpoint of Y and Z to find what the midpoint coordinates are according to X. And
Yes.
then from there, we can just do slope and Y equals MX plus B.
Perfect. But you can extend this question to find the point, that centroid, the intersection of medians, right? And then
Yes,
also you can use the same example to verify that it actually bisects the line in the ratio of 1:2. Is that clear to you? So you can actually extend and learn more from these examples. You can go almost at the end of the video, see what we have.
okay, sir.
Yeah, click somewhere. Yeah, end of the video. That will give you the solution, right? So let's see more examples. So that was on 3.1 or 3.2 chapter, which is more properties on triangles, correct? But this is all the
Yes, sir.
analytical geometry. Now
Okay,
in
sir.
this, find the equation of median. Okay, go to the end. We'll see more examples. So
So
there are 9
circle.
questions which we are talking about. Can you read question number 9?
Okay. So determine the length of a chord from x-intercept to y-intercept of the circle. X squared plus y squared equals 49.
Correct.
So sir, the x squared plus y squared equals 49 is to help find out the radius, right, sir?
Yes.
According to point of origin.
Yes, yes, yes.
And sir, a chord is basically where two lines which are on the circle but do not go through the origin, right, sir?
Yeah,
Or the
that'll be a
midpoint.
diagonal. So diagonal is the longest chord. Diagonal is the longest chord, okay? Diagonal
Okay,
comes
sir.
to a chord. It is the longest chord, right? Well, this is a simple question. You know the radius is 7, and therefore forming a right angle triangle isosceles
It should just be 7, sir.
hypotenuse, use Pythagorean theorem and get your answer. Is that clear to you? However,
Yes, sir.
we have touched upon most of the topics, most of the type of questions which are expected in test on this particular unit. So I'd like you to go through some of them later. Is that okay? As an extra. So Rohan, did you understand all we talked about the quadrilaterals today in the class?
Yes, sir. I was able to understand about the quadrilaterals and know like some rules. For an example, like special shapes like kite, rhombus, square, all when doing diagonals intersect at 90, having to correlate with the length, midpoint, slope, and y equals mx plus b when solving the equations
Yeah, yeah.
is something else.
There is one more type of question which is normally asked in test papers. It is extended, where in a quadrilateral, we are normally in a parallelogram, we are given 3 coordinate points and you have to find the fourth. And in a triangle, we are given some condition and you have to find the missing coordinate. So that could be a very good question to prepare. I'd like you to go to my YouTube channel and just search, just type in Anil Kumar, find the missing coordinate and see what type of examples you get.
Okay, sir.
Share the screen.
I'm just trying to type it. Anil Kumar. Which one?
Find missing coordinate of vertex.
Of vertex.
Yeah. And then share the screen. I'll tell you which type of questions I'm looking into.
All right, sir. I think I might have found the video.
There are a couple of videos. So that's why there are many of them. So now look at the first one. Can you please read the question? Find the missing points on the rhombus where diagonal vertices given to you, right? So as we have seen, we have to find a missing value, correct? So in this particular case, missing value is at A. You see that at A, there's a missing value, right? So since you know the properties of rhombus, all sides are equal. You also know that the opposite sides are parallel. So you can actually find the missing point. You get the idea?
Yes, sir.
So it's a very interesting question. However, I will show you how to find that missing point in the simplest possible way. That is the beauty of this particular video. So I'd like you to go through this video and see how easily we can find all the missing points. And here you can see there are a couple of missing points. C is XY. We are not knowing that point at all, right? So we have to find C also. So apart from A,
A.
which is A0, we have to find also C. So there are two parameters. We know the lengths are equal. That is one. And second, we also know the slope is equal for all of them, correct? So using these concepts, we are going to find the missing points. Is that clear to you?
Okay, sir.
Search for the other video. Now again, click search here. I'll look into more different types of questions on this concept of finding the missing point. Just
Okay, sir.
search.
Just give me a second.
Yeah, just search again.
What is it, sir?
No, just same thing.
Oh,
Same
same
thing.
thing. Okay, sir.
Yeah, just search the same thing. Like missing coordinate, Anil Kumar. Write my name because my videos are not very popular. So once you write my name, then they pop my videos, right?
Anil Kumar missing coordinates
Yeah.
of vertex.
Okay.
There.
So next one also, find fourth vertex of rectangle coordinate geometry, right? So we have a question here in which, can you read the question?
Oh, so the points A, B, C, and C are three vertices of a rectangle A, B, C, D. Find the coordinates of point D.
Correct. Next one, after this, slope challenge.
So find all coordinates of a square when there are two given. So the
Correct.
coordinates are two vertices of a square 0, 3, and 2, -1. Find the possible coordinates of other two vertices.
But possible means it could be on either side, and therefore we have two sets of values. And that's kind of very important to understand. You get the idea, right? Move further.
Yes, sir.
Move further. See, there are move this. That's the next is again a test question. Can you please read this question?
So ABCD is a rectangle. The point A is 210, B is -1 and 6, and C lies on the x-axis. Find the coordinates of point D.
Correct. Likewise, there are so many, right? So rectangle, parallelogram, rhombus, any shape, any quadrilateral, right? Even in triangles,
Yes.
yeah. So if you scroll many of these videos, just go through them. Yeah, continue.
Yes, sir.
Continue going. Find. So we have so many conditions. You get the idea, right?
Yes,
So
sir.
look into these videos also. They are kind of very important questions, not normally discussed in the books, but
Okay, sir.
we see them in the test papers. So that's the whole idea. Perfect.
Yes, sir.
So I think that's a good point, and hope that helps. We can end our class at this stage. Okay, Ron?
Okay, thank you, sir.
Thanks. My pleasure. Have a great day. Bye.
You too, sir. Goodbye.
Bye.